good morning to all of you. Today I'll start pressure as we have finished off what force. So we'll start pressure. So children, you have learnt in the class 7th that strong winds during a storm or a cyclone can blow away even the rooftops. You also learned that winds and cyclones are caused by the differences in air pressure. Is there any relation between pressure and force? Let us find out. For that, try to push a nail into a wooden plank by its head. Did you succeed? Try now to push the nail by the pointed end. Could you do it this time? Try cutting vegetables with a blunt knife and then with a sharp knife, which is easier. Do you get the feeling that the area over which the force is applied, the pointed end of the nail, plays a role in making these tasks easier? So, the force acting on a unit area of a surface is called pressure. This formula gives the relation between pressure, force and area. We will now give the units in which pressure is measured. The SI unit of measuring force is Newton and SI unit of measuring area is square meter. So therefore SI unit of measuring pressure is Newton per square meter, which is also called Pascal. Since the area is in the denominator of pressure formula, it means that larger the area of surface, smaller will be the pressure produced by a given force. And smaller the area of surface, larger will be the pressure produced by the same force. The area of the pointed end of the drawing pin is very small, due to which the force of thumb produces a large pressure on the piece of wood. This large pressure pushes the drawing pin into the piece of wood. From this discussion, children, we can conclude that pressure depends upon two factors: force applied and second is area over which force acts. The same force can produce different pressures depending on the area over which it acts. For example, when a force acts over a large area of an object, it produces a small pressure. But if the same force acts over a small area of the object, it produces a large pressure. Now children, I will explain you some everyday observations on the basis of the pressure. A school bag or shoulder bag has a wide strap made up of thick cloth or canvas so that the weight of the bag may fall over a large area of the shoulder of the child, producing less pressure on the shoulder. And due to less pressure, it is more comfortable to carry the heavy school bag. On the other hand, if the school bag has a strap made up of thin string, then the weight of the school bag will fall over a small area of the shoulder. A sharp knife has a very thin edge to its blade. A sharp knife cuts objects like vegetables better because due to its very thin edge, the force of our hand falls over a very small area of the object, producing a large pressure. And this large pressure cuts the object easily. On the other hand, a blunt knife has a thicker edge. A blunt knife does not cut an object easily because due to its thicker edge, the force of our hand falls over a large area of the object and produces lesser pressure. This lesser pressure cuts the object with difficulty. Now we will start pressure exerted by liquids and gases. The substances such as water, oil, Alcohol, petrol, and mercury are liquids. All the liquids exert pressure on the base, that is bottom, and walls of their containers. Though pressure is exerted by all the liquids, but since water is the most common liquid around us, therefore we will be using water as a liquid in our activities on pressure exerted by liquids. Activity 11.8 demonstrate that a liquid exerts pressure on the bottom of its container. Take a transparent plastic pipe about 15 centimeter long having a diameter of about 3 centimeter. Also take a thin sheet of rubber. Stretch the thin rubber sheet and tie it tightly over one end of the plastic pipe. Now, in this activity, the plastic pipe is the container which has a stretchable bottom made of a thin rubber sheet. Now, keeping the pipe vertical, let us pour some water in the pipe from the top end. We will find that on pouring water in the pipe, the rubber sheet tied to its bottom stretches and bulges out. The bulging out of rubber sheet demonstrates that the water poured in pipe exerts a pressure on the bottom of its container. This is because the bottom of the container, that is pipe, in this case is made up of a flexible thin rubber sheet which can be stretched by pressure exerted by water to form a bulge. Let us now pour some more water in the plastic pipe so that the height of water column in the pipe increases. We will find that as the height of water column increases, the bulge in the rubber sheet also increases, showing that the pressure of water on the bottom of its container has increased. In fact, greater the height of water column in the pipe, greater will be the bulge in its rubber sheet bottom. From this activity, children, we conclude that number 1, a liquid exerts pressure on the bottom of its container, and number 2, the pressure exerted by a liquid depends on the height of liquid column. One more important thing is that, children, the hard bottom of the containers like metal vessels or glass vessels, however, do not get stretched or bulge by the pressure of water kept in them. Now I am going to explain you that a liquid exerts pressure on the walls of its container. For this, we will take a plastic bottle, fix a small glass tube a little above the bottom of the plastic bottle. We can do this by heating one end of the glass tube slightly over a burner and then inserting this hot end quickly into the wall of the plastic bottle. Now tie a thin sheet of rubber tightly on the open end of glass tube. Now fill half of the plastic bottle with water. We will observe that on filling water, the rubber sheet tied to the mouth of glass tube gets stretched and bulges out. The bulging out of rubber sheet tied to the glass tube fixed in the wall of plastic bottle demonstrates that water present in plastic bottle exerts pressure on the wall of the bottle. It is the sideways pressure exerted by water which inflates thin rubber sheet forming a bulge. If we pour more water in the plastic bottle to increase its depth, we will see that the bulge in the rubber sheet increases. This indicates that the pressure exerted by water increases with increasing depth. So what we can conclude from this activity? we can conclude that a liquid exerts pressure on the walls or sides of its container. And number two, the pressure exerted by a liquid on the walls or sides of its container increases with increasing depth. Now I will explain you activity 11.10 that a liquid exerts equal pressure at the same depth. For this we will take a plastic bottle, make two small holes of equal size on the two opposite sides of the plastic bottle, some distance above the bottom of the bottle. The holes should be at exactly the same height from the bottom of the plastic bottle. Now fill the bottle with water. We will observe that the two jets of water coming out of the two holes fall at the same distance away from the base of the bottle on its either side. The two jets of water can fall at equal distance on the two sides of the bottle only if the pressure of water at the depth of two holes in the bottle is equal. So we can conclude that a liquid exerts pressure on the walls or the sides of its container, and a liquid exerts equal pressure at the same depth. Many times we see a fountain of water rushing out of the leaking joints or holes in the pipes of main water supply line in our city. It is due to the very high pressure exerted by water on the sides or the walls of the pipes that such a fountain of water is formed. So, the formation of fountains of water from the leaking pipes of water supply pipeline tells us that water exerts pressure on the walls of its container. As we live on the earth, there is a lot of air above us. So, the layer of air above the earth is called atmosphere. The air in our atmosphere extends up to 300 kilometers above the surface of earth. The atmosphere contains a tremendous amount of air, and we know that air has weight. So the atmosphere consisting of tremendous amount of air has enormous weight, and the weight of atmosphere exerts a pressure on the surface of the earth and on all the objects on the earth including ourselves. So this pressure is known as atmospheric pressure. So we can say that atmospheric pressure is the air pressure which is exerted by the weight of air present in the atmosphere. We know that pressure is force per unit area. Now, if we imagine a unit area of Earth's surface and a very tall column which is filled with air standing on it, then the weight of air has this column will be atmospheric pressure at that place. Since the SI unit of area is square meter, therefore we can also say that atmospheric pressure is equal to the weight of air present in a very tall column of air standing on 1 square meter area of the earth. On the surface of earth, the atmospheric pressure is maximum at the sea level. Why? This is because the column of air above us is tallest at the sea level. The atmospheric pressure on the surface of the earth is 101.3 kilopascals, which is equivalent to the weight of 10 elephants pressing on each square meter area. So, thus the magnitude of atmospheric pressure is very large. As we go up in the atmosphere from the surface of earth, the atmospheric pressure goes on decreasing. Why? This is because as we go up in the atmosphere, the weight of air above us goes on decreasing, due to which the pressure also goes on decreasing. So, the atmospheric pressure on the top of a high mountain will be much less than at its base. A rubber sucker is a device made up of rubber or plastic that sticks firmly to flat and smooth surfaces on pressing. A rubber sucker looks like a small concave shaped rubber cup. A rubber sucker is also called a suction cup because it sticks to a surface by suction. Production of partial vacuum by the removal of air is called suction. So children, when we press the rubber sucker on a flat smooth surface, its concave rubber cup gets flattened to a large extent, pushing out most of the air from beneath it. Since very little air remains inside the flattened rubber sucker, therefore the air pressure inside the rubber sucker becomes very low. The much greater atmospheric pressure acting on the rubber sucker from outside fixes the rubber sucker firmly on the flat surface. Thus, a rubber sucker stays attached firmly to a flat surface due to the atmospheric pressure. Rubber suckers are usually used to hold objects together with the help of suction. For example, rubber suckers are used to hold glass, tabletops onto the wooden frames of table. Rubber suckers are also used for making suction hooks which are fixed on walls, doors, almirah, etc. to hold various things. That's all for today video. Thank you and have a nice day.